Digital signatures. A digital signature is a mathematical scheme for verifying the authenticity of digital messages or documents. A digital signature provides authentication, non-repudiation, and integrity. Authentication provides recipients of a message confidence that the message originated with a specific entity. Non-repudiation provides the originator of a message with the proof of receipt of the message. Integrity is confidence the message has not been altered during transmission. Message to be signed is passed through a cryptographically secure hash function which produces a fixed-length output called a message digest. This hash value is then encrypted using the message author's private key to produce a digital signature. Digital signature is transmitted as an appendix to the message. When a recipient wishes to verify the document, recipient compute the message digest for the message as received. Then they decrypt the digital signature using the author's public key to produce the originator's message digest. If the two are identical, then the recipient knows the message has not been tampered. The message has originated with the owner of the public/private key pair. Digital signature does not protect the confidentiality of the message. If confidentiality is required, the sender must encrypt the message. Digital signatures' vulnerabilities are hash collision, private key disclosure, CA compromise. If the attacker can create two messages that generate the same message digest when put through a hashing algorithm is called a hash collision, then the digital signature is no longer reliable. In order for the recipient to have confidence that a message actually originated with the author, the sender's private key must remain secure, because with access to the key, an attacker can sign any message. If the certificate authority, CA, is compromised, attackers can spoof the identity of a public key and forge digital signatures.